welcome back to my channel. In this video we are still solving questions, the past question of math 122, that's calculus 1. So we are going to solve the second question, but before that, the second question involves one function that I want to clarify before we start solving that question, and that is the B part of the question, which is given that y is equal to sine inverse of x all square, shows that 1 minus x square d square y over dx square minus x dy dx is equal to 2. That we should show that this, if this is equal to this, then this follows. Okay, I want us to clarify something about this guy, the sine inverse of x. That's the reason why I'm recording this short video, to explain that one for you. Why is this guy, why is the sine inverse of x equal to 1 over the square root of 1 minus x squared? So in order to get this and understand it better, let's prove it ourselves. So let me close this. We have the question there, why is the sine inverse, the derivatives of the sine inverse of x equal to 1 over 1 minus x squared? So this is it. So let y equal to the sine inverse of x. If we let y equal to the sine inverse of x, then by definition sine of y equal to what? X. So if sine of y is equal to x, then y equal to what? Sine inverse of x. So let's differentiate implicitly. So the derivative of what? Sine y equal to the derivative of what? X with respect to x. So this means that sine y, the derivative of sine y will be what? We know that the derivative of sine x is what? Is cos x. So the derivative of sine y will be what? Cos y. But it is an implicit function. We add dy dx equal to the derivative of x is 1. So what we need to do is to what? Divide both sides by what? Cos y, because we are looking for dy dx, that's the derivative. And this will lead us to dy dx being 1 over cos y. But the this identity, we know that cos square of y plus sine square of y equal to 1. We know this, and we are looking for the terms in terms of what? Cos y, sine y. So we are looking for everything in terms of sine y. So we have to substitute this cos y by what? Sine y. And from here we can make cos y the subject. So cos square y equal to 1 minus sine y, sine square y. So we can take what? Square root of both sides. So you see that this will the square will take away the what? The root. Note that cos square y, so note that cos square of y is the same as what? Cos y all square, and that's why the square is just cancelling what? The root. All is fine. So we continue. Implies our cos y will be equal to what? The square root of what? 1 minus sine square y. But from here we know what sine y is. Sine y is the same as what? Sine y is the same as x. So we are now substituting x with sine y. And remember that if I have sine square y is the same as what? Sine y all square. And this will give me what? X square. So now we know that sine y square is the same as what? X square. So sine y square is the same as x square. So we have it there. So we say that sine y, so sine square y is equal to sine y all square, which is equal to what? X all square, x square. So now our cos y will now be equal to what? Square root of 1 minus x square. So let's go back and substitute this for what? Dy dx. So since dy dx, so since dy dx is equal to 1 over cos y, we will now have, and cos y is also equal to square root of 1 minus x. We now have our dy dx to be what? 1 over the square root of 1 minus x square. And this is what? The derivative of what? Of sine inverse of x. So we can confidently say that the derivative, so where dy dx is what? The derivative of what? Sine inverse. So it's the derivative of what? Sine inverse of x. So it's this. Okay, so this is it for now. So in our next video we'll look at the solution to the question 2. And mind you, you can use this approach to solve for the other three ratios. So just you can try them and find what you can also solve for what? The derivative of cos x. So you can solve for what? dx of what? Cos inverse of x using this same approach, and you will find that answer. So you can try it on your own time. So see you in the next video where we will be solving question 2 of our past question. Thank you very much once again. If you haven't subscribed to the channel, please do so, and see you in the next video.